to the basics today. I think most of them are not there. Okay, so we'll try to cover the basics and then we'll do some basics, one or two examples to understand more about the measure of central tendency. Okay, so I'll just write it down the definition here. Okay, so what is statistics? Okay, statistics is science of collecting, organizing, okay, organizing, collecting, organizing, analyzing, and interpreting. Okay, interpreting data to make decision, informed decisions. Okay, so this is the definition. Statistics is the science of collecting. You have to first collect the data, then organize, okay, organize in a proper way, and then analyze the data, and then finally interpret it to make a decision making. Okay, so what does statistics helps with? Okay, one is understanding the data. Okay, understanding the data. Second one is identify patterns. Am I audible?
Yes, yes.
Okay, I'm getting echo, so I don't know. Okay, okay, and the third point that I think of is make prediction. See, whenever you get some piece of data, first you will organize that data in Excel sheet. Okay, normal. I'm telling normal, and then you will see which month did you make a good sales. Okay, which month, or if it is sports data, you will see who has scored highest run or highest wickets, right? So it gives you some prediction, right? So if you see the definition, it's a collection, organizing, analyzing, and interpreting. Interpreting is what you will say who has scored XYZ out of these 11 players, who has scored best. Okay, who is the second best, who is the third best. Okay, based on that, you will take a decision. And who has uh, frequently getting duck out in all the matches, he is the outlier, so that you will take a decision to not to uh, make him for the next games, okay, next match or whatever match you are playing. Okay, so we use these type of collection or I can say statistic we use in our day-to-day life. Okay, okay, these are the some of the points that I think of: understanding the data, identifying patterns, and make the prediction and decision. Okay, and decisions. Okay, what you can use probability, you can use probability and hypothesis testing. Okay, now let's understand types of statistics. Okay, so what are the type of statistics that are available for our learning is descriptive and inferential. Okay, inferential statistics. Okay, these are very important. Okay, now let's talk about descriptive. Okay, so what all fall under descriptive? So what is a descriptive statistics? Okay, descriptive statistics, what it does is it summarizes your data into a meaningful information. Okay, now what does it use? It use mean, center of central tendency. Okay, so what does that include? Mean, median, mode. Okay, and it also includes variance. What is variance? The distance from your average or mean. Okay, so you have a mean some value 40. Okay, how distance is your data points. Okay, if you are looking for a age, okay, if your age average age is 40, okay, but your distance, if you see 18, 16, okay, even 8 is there. Okay, now you see if you are doing some analysis whether a person with a age of 8, do you think that age is relevant for this exercise or uh, 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 I mean summarizing? No, right? Then you will remove those. Okay, so variance and standard deviation. So you will generally all these mean, mode, median are used variance this distributive statistics in sales data. Okay. Then they will also have something called range. Okay, so we'll see all these things with hands-on experience. Range, then percentiles, quartiles. Okay, all this. Okay, and the next one is, I'll just copy this, I'll paste it here. uh, Inferential statistics. Okay, inferential statistics, and under inferential, what are the things that fall? And now what is inferential? Okay, inferential uses data, okay, to make prediction. Okay, the difference between descriptive and inferential, you see, you summarize data into a information. Okay, in a descriptive statistics. Okay, but here what you do in inferential statistics helps in prediction and generalization. I'll write it down. Generalizations. Okay, and whereas descriptive statistics, what it does, summarizes, SUZES, summarizes data into meaningful information. Okay, So this is a definition for this and uses data to prediction. The difference between this and inferential. Okay, descriptive and inferential is use data to make prediction or generalization. Okay, so I have to remove this. Okay, so what all methods are included here? Hypothesis testing. Okay, okay. The other one is uh, confidence. CONF confidence intervals. And the other one is correlation or regression. If you remember, I've already showed you CO or a core, I mean the basics, okay, when we were doing this pandas and all. Okay, so these are the some of the methods for inferential hypothesis testing, confidence and correlation and regression. Okay, now we'll do some examples here. Okay, for my example, what I need is I need a sample data. Okay, now what I'll use is I'll use NumPy. Okay, import SNP. Okay, and then I want to create a population. Okay, a variable called population equals, it's a variable. Okay, I'll use np dot arrange a range. Okay, a range of number I want to create. Okay, say from 1 comma 100, so 101 I'll take. Okay, this is the number starts from, you know, the Python this thing starts from 0, right? So I have added 1, so it will take 1 to 101, so which is the last number? 100. Okay, now I'll create a sample. Okay, so I'll create another variable called sample equals np dot there is something called, why the drop down is not coming? Okay, I have to type everything then. Random dot choice, ch o choice, random dot choice. I'll use population here, population. Okay, that is my previous variable range. I 1 to 100 comma, that is my data, and then I will use the 10 random sample of 10. Okay, or 20, you can do anything 20 also. Okay, now I'll use the print statement. Okay, so first I'll run this. Let me check if I'm getting any error. Okay, no error. So I'll print my statement. Print. Okay, so first I'll take population mean. Okay, so I'll put comma. What is my population mean? I'll say numpy dot mean. Okay, mean is your average. So average of what? Population. Okay, so this is one, and another one sample of 10, right? That also we can take. I'll just copy paste sample, and here for the label I'll mention sample mean. Okay, so I'll run this. Let's see. Okay, so my population mean for 1 to 100 is 50.5 and mean for this, okay, with a choice of 10 random numbers, okay, 79.3. If I run again, okay, now you see it has changed to 36. It randomly changes. Okay, if I run again, 49, but mean will be same. But this 10 sample will keep on changing every time you run it. Okay, so that is the beauty of this thing. Okay, now we'll see measure of central tendency. Okay, now what all falls under measure of central tendency? Mean. Okay, what is mean? Average. Okay, other one, median. Median. Okay, what does this mean? Median means middle value. Third one is mode. Now what is mode? Repeated value, or you can say most frequent values. Okay, so we'll play around with this data for mean, median and mode. Okay, so what I'll do is I'll take different data set. Hmm, okay, import statistics as stats. Okay, short form. Okay, so these are all these library that you see, statistics, numpy, these are all included in Python. Okay, you don't have to install. Anytime you get any message stating that statistics is not found, okay, then you have to install. How do you install? You will say pip space install with the name of the library. Okay, now I'll take some data point. Data equals square. Okay, I'll take some number 5 comma 7 comma 3 comma 7 comma 9 comma 7 comma 10, some random number. Okay, list I took it. Okay, now what I have to do is I'll use the print statement. Okay, so I'll just take this. I don't want to type print mean. Okay, here I'll use median. Okay, and I need one more, mode. Okay, here instead of np I can say stats. Okay, stats dot mean, here I have to change to data. Okay, that is my variable. Okay, I'll run this. Let's see the results. So what is my mean? Mean is 6.85. Okay, so you know, everybody knows average. How we calculate? We sum up all these number total by number of events, 1 2 3 4 5 6 7, 7 divided by 7. So you get this median. Median is a value, mid value. Okay, so there is a calculation for that, n plus 1 by 2. Okay, that is the calculation for median. And mode, Mode is repeated value. What is the repeated value here? Nothing is there. Okay, so nothing is there, man. It will do the calculation of mode. Oh, sorry, I have written everything mean here. Okay, sorry, sir. Median mode. Okay, okay. Now you see, mean is 6, median is 7. Okay, mid value is 7. 1, 2, 3, 1, 2, 3, and this is the mid value. Okay, and what is mode? Repeated value. Which number is repeated here? 7. Okay, you can add some more numbers. Okay, for experimenting. Okay, I'll run this. So this is the value. Okay, you can calculate, guys. Okay, just spend some time to understand this. This will help you out. Okay, so what we'll do is now, if this is clear, any doubt, Sahib, Kiran? No? Okay. This is clear, right? Very pretty simple. Okay. Now what we'll do is we'll also see measure of dispersion. If you recall, okay, measure of dispersion. Okay, understanding the spread of your data. Okay, so what all includes range, variance, and standard deviation. Okay, so what is range? A range difference between the maximum and minimum value. Okay, and what is variance? The average of the squared difference from the mean, and standard deviation is the square root of the variance provided providing a measure of spread in the original unit. So for example, your standard deviation is somewhere. Okay, your mean is this point. Okay, so this mean, just assume this is only one bell curve is here. This, just forget about this. Okay, this is your bell curve, and this is your midpoint is your average. Okay, and you are seeing the standard deviation is somewhere here, points here and here. Okay, so you can see how far your points are from the average. Okay, so I'll tell you when we do this analysis, right? So you will know why this is very important. Why do we do this actually in sales? Okay, so in sales, the sales number that we get, right? So we need to see how different we are from the target, how far we are there. Okay, it gives all the calculation. So we're gonna see range, variance, and standard deviation. I'll mention uh, measure of dispersion. So simple dispersion means difference, how far. Okay, and the previous one, measure of central means mean, median, and mode. Okay, three of three m square, m cube, m3 we say. Okay, for to remember, you can say m3, median, mean, mode, median. Measure of dispersion. Okay, so what all that includes in measure of dispersion? Okay, range. Next is variance. Variance is nothing but how far your data points from the actual. Okay, and what is the other one? Standard deviation. Standard deviation. Okay, okay. Now I'll take some data point here also. Okay, I'll take just 8 data point. Okay. Okay, 1 2 3 4 5 6 7 8. Okay, so that you can understand with the example. Okay, I'll take this as data one because already we mentioned data here, right? So in the same notebook, so it will create some issue. Okay, so our data is ready. Now I'll print. So again, I'll take the same thing. Okay, and first one is I'll take a range. Okay, second one is variance. Third one is standard deviation. Okay, here I have to change it to stats. Range is equal to, so there is a different formula here. Okay, so what is the formula? We have to take the max data. Okay, in this block, what is the maximum data is there? Okay, we know 99, but what if we have 100 data points? Okay, you have to go through all these things, which will take a lot of time consuming. So simply we can say max of data 1. Okay, then I can say minus minimum number of data 1. Okay, second variance. Okay, now variance, how will you use? You can use numpy also. Simple. I'll change it to data 1. Okay, I'll say np dot variance. That's it. Okay, and third one is the standard deviation. Standard deviation. Okay, np dot standard, std, short form. Okay, standard deviation. That's it. Done. Okay, this is np dot variable blah 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 variance. Done. Okay, now I'll print it. Okay, so it says okay, there is a one comma missing. Okay, sorry, bracket. Okay, now it is there. Okay, so range is 94. Okay, so even if you open a calculator, okay, so what is the max number here? 99 minus what is the lowest? 5 minus 5. 94. 94 is our range. Okay, now variance. Okay, now if you see variance here, 800 point some 98. Okay, and here standard deviation of 28.3. Okay, which is the overall standard deviation for this data point. Okay, if you add single digit number, you can understand better. Okay, so I will just copy this. I'll put this in comment. Okay, so I'll click on this. Okay, now what is the range? 7. Okay, highest number, what is the highest number here? 9. What is the lowest? 2. 9 minus 2, 7. Okay, and variance you can see 4. 4.7 is the variance from the data point. Okay, and what is the standard deviation is 2. 2.17 is your standard deviation from your mean. So each data point that is falling. Okay, when we bring this data into your chart, right, scatter chart or other charts, right, you can easily identify those. Okay, how far your data is from your actual mean. Clear? Okay, just let me. I think I've shared this PPT presentation with you guys, right? Yesterday. Uh, okay, so same thing we did descriptive, inferential. Okay, so it consists of organizing, summarizing, and visualizing data. Okay, so whenever we talk of central tendency, central means mean, mode, median. Okay, measure of dispersion. Okay, so we have mean, variance, standard deviation, and range. Okay, mean deviation is also there. Okay, what are the different type of distribution of data are there? Bernoulli, uniform. Uniform is just like a bell curve. Okay, binomial, normal or Gaussian, exponential distribution or Poisson. Okay, so this anyway will do it. Uh, so this I got it from some internet. This was very good. Okay, so you have a descriptive here. This is your sample. This is your entire population. Okay, so from there you will pick up some sample and you will start working on it. Okay, so we denote that with n. Okay, population data n, or sample data n. Okay, population is your entire data and small n denotes your sample. Okay, so these are the naming convention you have to use. Now let's talk about data. Okay, you know already everybody, right? Categorical and numerical or quantitative we called it. Okay, so in categorical what all falls under is normal data. Okay, like gender, blood group, color, location, cities, days, and ordinal. Okay, customer feedback. Okay, you have something score within a scale of 1 to 10, 1 to 5. Okay, this is called ordinal. Okay, discrete is whole numbers. Okay, number of children in a family. Okay, number of spikes, number of people, number of student in a class. Okay, continuous data is any value. It could be any value. House price in Bengaluru or length of river. Okay, it could be 10 kilometer, 12 kilometer, any value. Continue, it should be continuous. Okay, so these are the terminology you should be remembering. Okay, scale, the variable or number are defined, categorized. This you know. Okay, nominal or this very basics guy. Okay, very. I'm gonna share this. I've shared this. Correct me, guys, if I shared this or yet to share.
I
Let me
think
know.
you need to share.
Share it. Okay,
You
I'll
didn't
share.
share.
Yeah, descriptive is measure of central tendency that I was talking about. We just saw. Okay, see, most of these are very simple, guys. Okay, most of these are very simple. If you practice, it will be very easy for you. Okay, like I said, mean. Okay, how do you calculate mean? X plus x2, whatever the numbers you have, 10 numbers in our examples. Okay, you add, sum this. Okay, and then you will divided by n. N means number of observation, how many times it repeated. So here if you see how many times, 1 2 3 4 5 6 7 8 8, you sum of all this by 8, you will do it 8 and then you will get your average. Okay, median is a middle value data set. Okay, arrange in ascending or descending. First you have to arrange your data in ascending or descending and then you have to pick the mid value. Say for example, this is an example. Okay, this is an example. Yeah, here it is. Okay, so when you put it in Excel, this is how it looks like. So this is ascending. Okay, higher to lower. Okay, now you see, you will divide this 1 2 3 4 5 6 7 8 9 10 11 12 13. 13 means 6 by 6. Okay, you will take 6 here, 6 here. So what is your median is 12. Okay, 12 is the median or mid number that has 6 values above it and 6 values below it. Okay, now it can be one number or two number also. This is the example. Okay, so it could be two numbers. Same thing, you arrange the numbers, and then you will get two numbers also. Three numbers also you'll get. Okay, when you get two numbers, you have to 27 plus 20. You sum that up by two. Okay, if you get three number, you sum of all three and then by three, and whatever the number you get, that's your median. So it's a given data distribution is 28. Okay, mode. Mode represents the frequently occurring value in the data set. Sometimes the data set may contain multiple modes. Okay, so in this, see, there is more than one. This one, okay. Second, which one you see? This one and this one. Okay, so most frequently number 5 here in this example. Okay, now here measure of dispersion. Okay, so like I said, dispersion is the state of getting dispersed or spread. Okay, how your data is spread. Okay, always recall or remember your bell curve. Okay, so you can see when you put your data in a bell curve, you will see how your data is spread. Okay, we're going to do all these things in the advanced level of statistics, where you're going to spread your data, sales data or whatever data. Okay, and then we'll see what is your data is telling. Okay, so statistical dispersion means the extent to which a numerical data is likely to vary about an average value. In other words, dispersion helps us to understand the distribution of data. Okay, I'm going to share this, guys. This is just a handy refresh content where you can just refresh your knowledge. Okay, variance. This is the formula. See, but in here we just add np.var. Okay, so internally it does the calculation something like this. Okay, so what is the formula? Variance square is equal to sorry, simple variance is equal to 1 by n minus 1 sigma n, I is equal to 1, x is to I minus x. This is your mean with a square root of 2. Okay, simple variance, it's the observation of given data, this value xi observation. How many observation are there? If you have 10 or 8, that is your observation. Simple mean, average, you will take it and put it here. Okay, sample size, what is the sample size? Number of data value. Okay, 8 minus 1. So when you calculate, you get that number. Okay, you don't have to see all this, you need to know, that's it. Okay, you don't have to by heart all these things, it is not required, because when we have all this formula here, okay, or the function which is already readily available, you have to make use of all these things. But you should know what does this mean and all that, right? And what is the standard deviation? Yeah, this is the actual this one. Yeah, standard deviation is the square root of variance, whatever the variance we get, right? The number variance. Okay, the square root, when you square root the square root of the variance is known as standard deviation. Okay, standard deviation is equal to square root of variance, whatever the value you get here with this formula, the result, if you square, if you square root of the variance is called standard deviation. Okay, now what does it do? It is used to determine how estimation for a group of observation, that is your data sets, are spread out from the mean. So like I said, this is your bell curve. Okay, and this curve that you see, it never touches this line x value. Okay, x axis never touch, but here it is showing, but it never touch, it just goes above that. Okay, it never touch. Okay, so here determines how estimates for a group of observers, that is your data set, are spread out from the mean. Just assuming this is your mean number. Okay, and you can see how your data are spread out from your average. When your data are within this range, minus 1 to 1, okay, within this range. Okay, so we called it, it is a bell curve. Okay, your data is uniformly spread out. Okay, so this is very important, guys. I'm going to share this. Okay, just keep this and save it in your drives so that you can refer this. Okay, Now random variables. A random variable is a process of mapping the output, okay, of a random process or experiment to a number. Okay, example, tossing a coin. Okay, so you can get tails, heads, right? So random variables, okay, these are just a definition. Rolling a dice, you play a game, right? Dice, we have two that rolls, right? When you roll it, a dice, you'll get, there is a probability that once in six you can get six dice also, or five, or combination, right? This one and all we will go through it. These are sets, okay, some number is there, okay, and A union B, okay, when you are doing the intersect, this is how it does, okay. So this point that you see, it's, we say is A intersects B, okay. Now how you will define this red point? You see here, we have a sample data. Variable A has 1, 2, 3, 4, 5, 6, 7, 8. B value has 3, 4, 5, 6, 7. Okay, now what is same here? 3, 4, 5, 6, 7. 3, 4, 5, 6, 7 is same in B. So it will intersect at this point. Okay, so you can say intersection A union B. Okay, sorry, A intersection B. Okay, A union B is what? You can see here, 1, 2, 3, 4, 5, 6, 6, 7, 8. Okay, so histograms, skewness. Okay, so I've already given you histograms, right? So if your histograms is something like bell curve, right, then we can say your data is uniformly distributed. So I have a age here. Okay, some random ages are here. Okay, and I have bins of 10. Okay, bin size of 5. So here 5, 10, 15. Okay, these are all bins. Okay, so I have pointed all my data points there. Okay, 42, 75, 40 is there. Okay, 75 we don't have. Next is 50. Okay, 50. So something like this. If you see here, your data is going like this. Yeah, this one. When your distribution, data distribution is something like this, we call this as a normal distribution. Okay, and you can see this is right skew, little on the right side. Okay, and when you get a curve something like this, then we say is left skew. Okay, now when you see something this like this, you say uniform. Say for example, you have a value here, you have different values. What if I put everything as 14, 14, 14, 14, 14, 14, all how many values are here? If I change it by 14 one value, you will get something like this. Your data is uniform. Okay, so skewness, this example, okay, or it's called normal or Gaussian distribution. Symmetric, okay, this is symmetric like a bell curve. Okay, no skew. Okay, we called it a no skew is when it is lightly on the right side uh, or left side. Okay, mean, median, mode. Okay, mean is equal to median equal to mode. When all these are equal, then we say no skewness. Okay, right skewed. So you can see in your histogram, you have a highest value, then going less, 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 something like this. Okay, so whenever you see on the right hand side, it's called positive skewed. Okay, this is called positive skewed, where your mean will be greater than your median and median will be greater than your mode. Okay, these are the fundamentals. Okay, when you have a data something like this and your uh, bar is your graph is going like this, then you will find outliers. That is what it say. Okay, so you can easily find out outliers. Okay, if your mean is greater than median and median is greater than mode, then you will your graph will something like show towards a right skewed where you will have some outliers. So you have to treat those data, remove, and then you have to do your computation. Okay, left skewed. Okay, left skewed means negative skewness, minus. Uh, when your mean is less than median, median is less than mode. Okay, sampling technique. So you have a entire data set. Okay, or I can say some 10,000 rows column is there. Okay, that is your entire population. Okay, you are taking some sample from it. Okay, so 10,000 rows constitute for 1 year data, right? 1 year ticketing data, support data. In that you will take 1 quarter. Okay, Jan to March, Jan, Feb, March, that is 1 quarter, right? So that denotes your sample. Okay, so this is the examples, guys. These are all very important. Okay, just go through it. This is very simple English statement. I don't have to explain all these things. You can do it yourself also. Okay, but I'll share it today. I'll share
Okay.
it all this thing, and this cluster sampling and all we'll do it when we get into what is that called, machine learning. Okay, so machine learning is little tricky here, but we'll see. Okay, we have to see, this is a very good article. I mean, I PDF I downloaded from Byju's or somewhere, I don't know. Okay, so it was there from a link I downloaded. Very good. Even I was referring this. Okay, it is refreshing my knowledge also. What is continuous data? Okay, something continuous, a person's height, time, distance. What is discrete? A number of students in a class where you cannot increase. Types of probability: discrete, continuous, distribution. Okay, so I'll do one thing, I'll share this today. Okay, so what's the time now? 9. Okay, we are on top of the hour. So we'll close this today. So we'll do this basics only. I'm going to share this and this PDF file as well. Okay, give me a minute. I'll share it. You can stop the recording